Hello friends, today we will see how to solve some questions based on Euclid's division lemma that appeared in the past couple of board exams. So let's quickly see the first one. The first one is from CBSE year 2020 maths paper. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3q or 3q plus 1 for some integer q. So friends, let's see how to tackle such questions based on Euclid's division lemma. Firstly, do you remember Euclid's division lemma? You may need to memorize this, as it will come in handy to solve questions like these based on it. So, let's recall Euclid's division lemma. Given positive integers a and b, there exist unique positive integers q and r which satisfy the equation a is equal to bq plus r, where r is greater than or equal to 0 and less than b. Now, in the given question, it says that we need to prove using Euclid's division lemma that square of any positive integer is either of the form 3q or 3q plus 1. Friends, always remember, when you get such kind of proofs in the exam, always start with what is asked to be proved. Here, you can see that the number before q is 3. So, we start by saying, let us assume that a is a positive integer and b is equal to 3. Then, by Euclid's division lemma, we can write a is equal to 3q plus r. Also, r is either 0, 1 or 2, since r is greater than or equal to 0 and less than 3, as per Euclid's division lemma. Now, let's evaluate the equation for each of these values of r, starting with r is equal to 0. Here, we get a is equal to 3q. Now, we need to find a square. So, squaring both LHS and RHS, we get a squared is equal to 9q square. However, we can also write 9q square as 3 times 3q square. If we denote 3q square as a positive integer k1, we get a square is equal to 3k1, where k1 is a positive integer. Now, we simply have to repeat this process for the other values of r, namely r is equal to 1 and r is equal to 2. When r is equal to 1, after squaring both sides and simplifying, we can substitute 3q square plus 2q as k2, where k2 is a positive integer. Hence, we can see that here a square is equal to 3 times k2 plus 1. Finally, let us take the scenario where r is equal to 2. On squaring both sides and simplifying, we can substitute 3q square plus 4q plus 1 as k3, where k3 is a positive integer. Hence, we can see that here a square is equal to 3k3 plus 1. From the above three scenarios, we have proved that the square of any positive integer is either of the form 3q or 3q plus 1 for some integer q. Hence proved. Let's look at another one. This one is from CBSE 2019. The question is, show that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. So friends, where do we start from? Yes, absolutely. We start by stating Euclid's division lemma. Come on, let's say it together. Given positive integers a and b, there exist unique positive integers q and r which satisfy the equation a is equal to bq plus r, where r is greater than or equal to 0 and less than b. Now, in the question, the number before q is 4. So, let's say a is a positive integer and b is equal to 4. Then, applying Euclid's division lemma, we can write a is equal to 4q plus r, where r is greater than equal to 0 and less than 4. That is, r is 0, 1, 2 or 3. Let us first take the situation where r is equal to 0. We get a is equal to 4q. But 4q is divisible by 2. Hence, here a is an even integer. Now, if we take r equal to 1, we get a is equal to 4q plus 1. Here, 4q plus 1 is odd. Hence, here a is an odd integer. When r is equal to 2, we get a equal to 4q plus 2. Here, 4q plus 2 is divisible by 2. Hence, 4q plus 2 is even. Hence, a is an even integer here. Finally, when r is equal to 3, we get a equal to 4q plus 3. Here, since 4q plus 3 is odd, a is an odd integer. From the above 4 scenarios, we can conclude that every positive odd integer is of the form 4q plus 1 or 4q plus 3. Hence, proved. Friends, hope you got a reasonable sense of how to go about solving questions related to Euclid's division lemma. Here are some short quick tips for you to remember. 1. Always memorize the theorem. A is equal to bq plus r, where r is greater than or equal to 0 and less than b. 2. Look at the number appearing in the question before q and use that as the value for b to start with the proof. Hope this was helpful. See you all in the next video.